I think at least when I hear you discuss, people think of it as a sort of a robot company, and you do have robots.
Yeah.
But a lot of your technology is software optimizing
That's right.
the robots. Is that right?
That's right. Yeah. So when you understand how Kiva's system works, moving the inventory around the warehouse, what you realize very quickly is we've really transformed the atoms into bits. Yes, the red, green, and blue pens have to move around, but what we're doing now is because we have mobile robots to move them around the warehouse, we have transferred the problem to a software problem. So any kind of store, move, and sort algorithms that you can come up with in software, we can now implement because the robots can physically move the goo around the warehouse. It's a very interesting twist on how warehouses operate. And so as a result, we have a large software group at Kiva that has developed an enterprise class application that's literally talking to these hundreds or thousands of robots, directing the traffic, optimizing the storage, movement, and sorting of this stuff.
And I assume there's like predictive algorithms for what should be like restocked where and all sorts of other kinds of
a little bit, predictive is a little bit strong of a word for us. We took an approach at Kiva where we do real-time heuristics. And it's a bit techy, but the point is, instead of waiting and making decisions about what might be optimal and doing an optimal calculation, we run all of our algorithms in real time. We say, which is the best pod that I can use right now? Where's the closest robot right now? And that way we can do tens and hundreds of thousands of calculations a second and talk to all these robots. And of course, it's all parallel processing now. In fact, the whole approach turns the warehouse into this giant parallel processing engine where you can fill orders.
I mean, you literally, though, the system has to like literally direct traffic and things. We'll also get to the video in a second, but like these, you have these things running around, and you have to say like, okay, give this guy priority versus this one. Is that right?
That's right. And again, those are conversations. So the way we talk to the robots, of course, is over Wi-Fi. So when we started the business, 802.11 had just kind of come into its own. So we have a wireless Wi-Fi conversation with all, call it 1,000 robots in the warehouse, and they're checking in with the host system for path planning and route management instructions and just job instructions in general. So it's a continuous conversation that we're having.
Interesting. So let's we have some video here, which I think is the best way to illustrate it.
I'll just give you a quick overview. You've got here a warehouse. This is in fact a Staples warehouse in Pennsylvania with about 10,000 different items of inventory on these blue shelving pods. So you have your red pens out there, the green pens, the yellow Post-it notes. They're all out there somewhere. And here's your pick-pack worker in a station. And what's interesting about this approach is now, without leaving her station, she has access to every single item of inventory in the building. And that's fundamentally powerful. And the process becomes very simple. Pod pulls up, you pick the item out, scan the UPC barcode, pack it into the carton, and press the button. And by the time she turns around, there's another pod there. So without leaving her little orange mat, she not only has access to every product in the building so she can fill any order, she can also do 2 to 4 times as many orders per hour as she used to do the old way.
So each box is an order, and then it has a list of items, and she just puts them in the computer.
That could be your internet order right there, and she's filling it directly. And not only is she filling it directly, she's doing the whole order. So if you order red, green, and blue, she's going to put all 3 lines in there. It's a very high fidelity pick process, which leads to some of the most accurate order fulfillment.
So that entire, all of those shelves we see there are mobile.
That's right. That's right.
So the entire warehouse is moving, with the exception of the people and their stations.
That's great. We put the people on the perimeter and make them stationary, and the rest of the distribution center becomes this kind of living, breathing organism.
Yeah.
It's so portable. We've had 2 customers now pick up their warehouse and move it over a weekend. So in the case of, what's interesting about this approach is that you can continue to grow and expand your warehouse over time. And when you run out of room in your current building, you can pick up your Kiva and take it with you to the next building. And you can do that now over a weekend, which is the kind of thing that just wasn't conceivable with prior automation.
And this applies pretty much only to distribution centers, or are there other types of, like, you don't do factories, and you don't do or manufacturing rather?
We've, as a startup, small company, we've had to focus on a particular problem, and the problem we set out to solve was pick, pack, and ship. It's a very labor-intensive thing in these warehouses. Once we created that, we realized what we had was a generic system for storing, moving, and sorting items of inventory. Now, those same principles would apply in a manufacturing setting, maybe you're building a car on an assembly line, you need the car handles and the windshield blades and the tires to show up along the line. As opposed to store, move, and sort, though, what you need there is just move the inventory and sort it to the line. And so we envision in the future being able to serve the manufacturing community with interesting versions of the Kiva solution. We haven't spent any time or energy on that yet, just because we're
still have a huge opportunity.
Yeah, we're growing so fast in e-commerce right now. That's where we're spending our energy.